Alright, today's lesson is on dilations on the coordinate plane. So let's go ahead and start off and discuss what dilation is. Dilation is a transformation that moves each point along a ray, which starts from a fixed center and multiplies distances from this center as a common factor. Since the new image is similar to the original, but not congruent, it is called a non-rigid transformation. So because we're not making the objects or the shapes congruent anymore, they're similar, we're going to have some different sizes with the dilation. Alright, and they're going to be moving by a scale factor. Okay, so they're either going to decrease or they're going to increase in size. So let's go ahead and start with our first example. Alright, it says identify the scale factor. So we're going to go ahead and use our coordinate points to do that, our ordinate pairs, our order pairs. So the original order pairs of A looks like we have a 0, 1. B, we have a 3, 3. And C, we have a 3, 0. Right. We're then going to go ahead and look at our A prime, which is 0, 2. Look at our B prime, which is 6, 6. And our C prime, which is 6, 0. Okay. Now if we go back up to the definition, it says multiplies distance from the center as a common factor. So we have to figure out how much these are increasing by each one. So when I go from 0, 0, I really can't tell what's happening there. But when I go from 1 to 2, I'm multiplying by 2. When I go from 3 to 6, I'm multiplying by 2. Same for this 3 to 6. When I go from 3 to 6 here, I'm multiplying by 2. And again, I can't say anything that's happening from 0 to 0. Okay? So it looks like I'm multiplying by 2 every time. Another way for me to check and see what it is I can actually use the lengths of sides. So BC is very easy to use in this case. So if I look at the length of BC, I have a 1, 2, 3. It is 3 units. Then if I look at B prime, C prime, I have 1, 2, 3, 4, 5, 6. 6 units. Notice how to go from 3 to 6 again, it is times 2. So for this answer, for this question, I have a scale factor of 2. Okay. Let's go ahead and look at number 2. We have now identify the scale factor again. So again, I'm going to go ahead and look at my original ordered pairs. So in this case, I have a larger shape to a smaller shape. So my original ordered pairs for this one, I have a 3, 9. For B, looks like I have a 6, 9. For C, we have 3, 3. And for D, looks like we have a 6, 3. Let's go ahead to our A prime now to see how about our new ordered pairs. A prime is 1, 3. B prime is 2, 3. C prime is 1, 1. And D prime is 2, 1. Okay. Now let's look and see what happens. To get from 3 to 1, it looks like I divide by 3. Same goes for my 9 to 3. To get from 6 to 2, I'm dividing by 3. Same for 9 to 3. To get from 3 to 1, same thing, I'm dividing by 3. And to get from 6 to 2 and 3 to 1, I'm dividing by 3. So in this case, you can see I'm dividing by 3 every single time. All right. Now let's go ahead and look at our lengths of our sides. So CD is what we have. If we look at the length of CD, we have 1, 2, 3. And then we look at the length of C prime to D prime, we have an length of 1. A length of 1. Same idea, we divide by 3. Now the key to this one though is that we have a scale factor, okay, and it's a multiple of it. Alright, so when we talk about multiplies, we're not going to divide. So if we think about what is the same thing as dividing by 3, you should come up with it as the same thing as multiplying by 1/3. Okay? And if you think of our old fraction rule, instead of dividing, we keep, change, flip. We would keep the first number, change our symbol to multiplication, and then flip it. So instead of 3, it turns into 1/3. So this one has a scale factor of 1/3. And if you compare these two, notice how number 2, our prime rectangle is actually getting smaller. That's why we're multiplying by a fraction. In the first one, we have a smaller one and we get larger, and that's why we're multiplying by the whole number. Okay. All right, let's look at number 3. We have enlarge the figure with a scale factor of 2, which means I'm going to be multiplying everything by 2. So let's go ahead and write our original ordered pairs. Our original ordered pair for A is 1, 2. Original for B is 2, 2. C is 0, 0. And D is 3, 0. So because my scale factor is by 2, I'm going to be multiplying everything by 2. Okay? So my A prime is going to be 2, 4. B prime is going to be 4, 4. C prime is going to be 0, 0 still. And my D prime is going to be 6, 0. So let's go ahead and draw this on there first. So A prime 2, 4, come on to 2, go to 4. B prime is 4, 4. 4, 4, B prime. C prime is 0, 0, stays right there. And D prime is 6, 0. D prime comes all the way over here. Let's go ahead and draw these now. And as you can see, it's the same shape, but just a different size. So it's a similar shape, and yes, it is larger than it. Okay. Let's go ahead and check to make sure this works by using our lengths of our sides. So let's go ahead and use the length of CD. So the original length of CD was 1, 2, 3. And then my length of C prime, D prime, if I look at my graph here, goes from 0 to 6, so is a length of 6. And yes, that does have a scale factor of times 2. All right, let's look at number 4. Now we want to reduce the figure with a scale factor of half, so we're going to be multiplying our coordinates by halves. Let's go ahead and look at our original coordinates first. A is 2, 4. B is 4, 6. C is 6, 4. And D is 4, 2. Again, my scale factor is going to be multiplying it by half. Multiplying by half is the same thing as dividing by 2, so I'm really just dividing all of these by 2. So I get a 1, 2, 2, 3, 3, 2, and then 2, 1. Let's go ahead and draw this on our coordinate grid to make sure it works. So A prime is 1, 2, B prime is 2, 3, C prime is 3, 2, and D prime is 2, 1. So I keep my diamond shaped, but because I'm multiplying by a scale factor that is a fraction, it does get smaller. So it looks like we're good. Let's go ahead and check to make sure by using our side lengths. The one they chose is BD, which doesn't make sense, it's not a side. So let's go ahead and actually they did do BD, because it's easier to do right down the middle there. Okay. We do 1, 2, 3, 4. So the length of B to D is 4. And then if I look at the length of B prime to D prime is 2. So yes, that is multiplying by a half or dividing by 2. So that is the correct scale factor. Alright, so now let's go ahead and have you pause the video. And I want you to go ahead and try yours. If you need to look back and see how we did the original ones, go ahead. Right, let's look at 1 and 2 here. Alright. So number 1 has us identify the scale factor. You should have found that your original points there, 1, 3, 1, 1, and 3, 1. And then your new prime ones are 3, 9, 3, 3, 9, 3. And you should have found that is a scale factor of 6, and that's proven in our length of our side of BC goes from 2 to 6 times 3. For number 2, you should have gotten a scale factor of half. This, in case it gets smaller, so that's why our scale factor is a fraction, and it's proven by our length of side of BC being 4 to 2. Number 3, you should have gotten it is a scale factor of 6, so you should have looked at your original ordered pairs, multiply them all by 3 to get your new original pairs, draw it on there, and then you should have checked to make sure that your length of side for CD should have been 2 to 6, giving you a scale factor of 6. And then lastly is a triangle with a scale factor of 4. Again, it should have decreased, so your original points 4, 8, 4, 4, 8, 4 should have decreased to 1, 2, 1, 1, and 2, 1 by multiplying by a quarter or dividing by 4, and you should have been able to check your length of BC versus prime BC 4 to 1. So that is our dilation video.